Okay, so this video is going to make us use our exponent rules to also help simplify any type of expression that doesn't just have exponents but has radicals or fractional exponents. So in this case, when I see this problem, I know that this radical freaks me out. I also know that this is an imaginary 2 on the outside of this radical because 2 is the imaginary number that's on the outside if nothing else is there. Otherwise, it would show me there's a cubed root or a quadruple root or a fifth root, etc. So I know that when I have something that's a fractional exponent, I usually bring that outside and make it a root. So if I see the 2 out here, that means that I know that this inside must have used to be, or I can switch it back to be to the 1/2 power. Now, that's good news for me because now I can use my rule and say, well, this 1/2 can distribute for everything. And I can try to simplify this a little bit because I see x to the 4th times 1/2 gets me x squared. Z to the 8th times 1/2 gets me just z to the 4th. Now, y cubed times 1/2 doesn't necessarily get me a pretty number. That would be 1.5. And I don't want to write 1.5 as a decimal, but I can still just write y to the 3 halves. I can write y to the 3 halves because it's still a fraction, and I'm just not going to simplify it into a whole number. Now, no one ever told me that I can't have a rational fraction as the exponent if there's no more simplifying to do. And I know there's no more simplifying because there's just an x, just a y, and just a z, so I know this is done. Let's move to the next one. Here we have just a regular old expression with no radicals and no fractional exponents, but we're just going to practice this. So you should be able to do this on your own, but just if you're confused still, I'm going to first simplify by getting rid of parentheses. So now I've got x, well 3 times 3 is 9, y to the 4th times 3 is 12, and z to the negative 1 times 3 is now negative 3. Underneath, didn't do anything. Now I see that I've got some z's that can be combined and some y's that can be combined. So I'm going to work with those. I know my x to the 9th is just there for good. Well, y to the 12th over y squared just means y to the 12 minus 2, so that's y to the 10th. Now z to the negative 3rd over z squared could happen two ways. I remember that negative exponents aren't good, so I could always take this and move it underneath to the denominator and make it positive. Or I could use my same subtraction rule as above that I used for my y and say, well, hey, this is z to the negative 3 minus 2, which is like z to the negative 5. And if the z to the negative 5 is on my numerator, I would want to put it on my denominator and make it positive. I would still do the same thing if I would have went with option 1, because z squared times z cubed is just adding exponents, which would be z to the 5th, and I would also still get z to the 5th on the denominator. Now I look at this fraction, I have 1y, 1x, and 1z, and that's as far simplified as I'm going to go, so I'm done. Let's take a look at the next one. Now here I see that there are roots, so I'm going to try to use my rules and make sure that I get everything as simplified as possible. I'm going to start with the numerator, with this 4. So if I distribute this to each term, even the x when it doesn't have an exponent, the x has an imaginary exponent of 1. So this would become multiplication. So z to the 3rd times 4 is z to the 12th. Y to the 8th, and x to the imaginary 1 times 4 is just 4. Now over here, I want to make sure I remind myself that a square root is also just like putting something to the 1/2 power. Now if I put this to the 1/2 power, I can distribute the 1/2 to both pieces. Well, like the first problem we just did, 3 times 1/2 doesn't give us anything pretty. We'll leave it at 3 halves. but 4 times 1/2 does. 4 times 1/2 is 2. So that's my new denominator. Now I see that I have x's and y's that I can combine. My z's are going to stay the same. There's no more z's to combine. I see y to the 8th over y squared. Well, that's just y to the 8 minus 2, which gives me a positive 6. Something's happening. There we go. Now I've got my x's. I have x to the 4th over x to the 3 halves. Well, in my rules, that tells me it's to the 4 minus 3 halves, which I'm going to have to do on the side here. Well, what is 4 minus 3 halves? Well, let's make this over 1. And I know when I multiply and divide fractions, it doesn't matter about the denominator. But when I add and subtract, the denominators need to be the same. So if I make these both into halves, well, 4 over 1 is the same as 8 halves, 8 over 2, minus 3 over 2. See here, 8 over 2, I didn't change the value. It still means 4, but now I can combine these and subtract. So 8 minus 3 is 5 over 2, 5 halves. So now this gets me x to the 5 halves power. It's also positive, so it becomes on a numerator right now. And now this is just over 1, which we all know doesn't mean anything. So I could drop the denominator and just have my z to the 12th power times y to the 6th power times x to the 5 halves power and be done. I only have 3 variables. There's nothing to combine, and I've done as much as I possibly can. And let's look at our final example. So this one gets a little tricky. I have a 1/2 on the outside, and then I have another parenthesis set on the inside, and I'm wondering, well, what should I do first? Doesn't matter, but I would always suggest that you go with the with the inside first. So I'm going to take this 1/2 and distribute it to everything after I do this inside set of zy squared. Well, the zy squared means that both things are getting squared, the z and the y. So this becomes z to the 2nd and y to the 2nd. And then x to the 4th and y to the 3rd did not change. Now we are bringing everything to be multiplied by the half power. So if we remember, when we have something on the outside, we distribute it to everything. And if we have something on the outside of a fraction, we still distribute to everything. So we're going to multiply. So x to the 4th times 1/2 becomes x squared. Y to the 3 times 1/2 is 3 halves. Z squared to the 1/2 is just z. And y squared to the 1/2 is just y. Now I look and I'm almost done, but not yet, because I see 2 different y's. I'm going to write my x's because I know that's done. I'm going to write my z because I know that's done and not going anywhere. I just have to take care of this final piece here. Well, I have y to the 3 halves over y to the imaginary 1. So on the side, y to the 3 halves minus 1 over 1. Again, not in the same denominator yet. I could do this in my calculator. If I wanted to, I could make this into seconds or halves. This really means 3 halves minus 2 over 2, because I can write 1 in any form. Well, 3 halves take away 2 halves equals 1/2. So I know that my exponents for y is y to the 1/2. I could also write this if I wanted to as x squared over z. I know that to the 1/2 power also means the square root of something. So I could write that as well. Either one of these is correct. if something told you specifically no radicals or specifically no fractional exponents, then you would choose one of them. But as you can see, there's two different answers here. They mean the same thing.